Hi everyone, my name is Igor. So I've been at Airbnb for about 2.5 years. Most of that time has been on the site reliability team, which has now been renamed production infrastructure. Very similar process as what you just heard in the keynote at Facebook. No one wants to be pigeonholed as the operations engineer. Um, and I've done a lot of stuff before that. Before that, I used to operate data centers for like just a pure data center operations company. And yeah, let's just talk about monitoring. That's what I've been thinking about a lot over the last year or so. And the things that I'm hoping to tell you guys during this talk is that kind of like what the context is, like how does monitoring enable the engineering organization at Airbnb? Like how does it fit into the broader picture? Kind of like some best practices, like what things have we learned through trial and error work well with monitoring and which ones do not work well. And then I'm also going to tell you a little bit about some of the tooling we use. This is like not specifically like you must use these tools, but like kind of what we look at in tools and how why we chose the ones we use and why we think they work well for us and might work well for you as well. So this is kind of like the agenda. I'm going to talk about engineering. I'm going to give you a little bit whirlwind tour of DevOps. I'm going to show you how we monitor our systems and the tools we use to do it. I'm going to show you how you kind of build these tools together to build a monitoring platform as opposed to just a collection of tools that stand on their own. And then I'm going to tell you a little bit about the alerts framework, which is a specific tool that we're going to open source. We kind of open sourced it for this conference, which is going to hopefully make it easier for you to manage your alerting. So the overall context at Airbnb, and this is probably something you hear from every tech company, is that we really want engineers to be able to move quickly. We don't want them to be like slowed down by like cumbersome processes that make sure that they didn't break something. We have an organization in which engineers deploy their own code. This is just a graph of deploys since we started tracking them in about 2012, since we built our automated deployment tools. You could see that it's been going up like pretty dramatically every year. 2015, we've already deployed more times than we've done in all of 2013. So this is going to be obviously like a really big deployment year for us. And in fact, we think it's so important that people be able to deploy and ship code quickly that my current role in the Airbnb team as a developer happiness engineer, this is actually my like top level metric. What you're looking at here is the wait, like this is the concept we call wait time. The blue line at the bottom is how long engineers have to wait to get a build. It tends to be about 15 minutes. We've actually gotten it down to about 10 minutes now. The purple line is how long engineers wait before their code can hit the staging cluster. And the yellow line is how long engineers have to wait before their code actually goes out to production. So we try to keep that under an hour. So like if you're ready to merge your code, it should like be out there like pretty quickly. Despite the fact that we're shipping code quickly, we don't want to break stuff because we have a lot of people around the world who are traveling to weird destinations. You don't want someone to get off an airplane trying to figure out where they're supposed to go to check into their Airbnb and just be like totally stranded. And when that happens, people get really unhappy. Also, we get a lot of customer service tickets, and that's not good. And especially sometimes because the customer service people use the same kind of infrastructure as like the production website, then the customer service people can't help you either. So we really don't want to break the site. How do we not break the site when we ship code that much and ship code this quickly? I think really there's two pillars to doing it safely. The first pillar is trusting the engineers. Like no one wants to break the site. People want to do the right thing. They want to be able to test their code. They want to make sure that their code is safe and doesn't like abuse the data stores or any other shared systems. But they need to be able to have tools that make it possible for them to actually ship code safely. And these tools are kind of like basically standard like DevOps tools. These are like all the tools that we give our engineers that like make it possible for them to ship code without breaking stuff. This is feature flags, which make it possible for you to ship code behind a flag, turn it on just to make sure it doesn't, or like maybe ramp it up slowly to make sure it scales, or like turn it off altogether without having to do a whole deploy to make sure that you can like roll it back quickly. We obviously have continuous integration. That means we always have tests running. We try to make them run really quickly. And we try to encourage people to have test coverage. People will write tests, especially if those tests run quickly, so they don't have to like always be waiting for their giant test suite to run. And we give people automated deploys. This is a screenshot of our deployment framework called Deploy Board. anyone who has a build out that is like passed by CI can just like push deploy and their code will go out. And if something goes wrong, the deploy will automatically abort. And also if like they know that there's a problem with their deploy, they can roll it back, like if something goes wrong after they're watching metrics. And of course, they have to be able to have some metrics to watch. This is a screenshot of our database metric watcher. Like if you deploy code and something goes wrong with the database, you should be able to know. Most of the time people watch NewRelic, and I'll show you guys what that kind of looks like. And then finally, we have automated alerting, which is there to make sure that if you do ship something weird and if it's affecting like business metrics or systems metrics, then someone, like hopefully your team, but somebody finds out about it and takes corrective action to bring functionality back. So that was kind of like a whirlwind like DevOps tour. Like these are all like pretty standard DevOps tools. Like there's nothing surprising here. So, but really what I want to focus on in this presentation is really just like on the monitoring component, because each of these things could probably take up an entire hour-long presentation. So how do we do monitoring? Although individual engineers and individual teams do own the responsibility for the code that they ship, and so it might be tempting to say, well, you know what, since you own the code, you can just monitor it however way you want to monitor it. But we do have like production teams that want to be able to jump in and help you if something really bad is going on. So we really wanted to pick like a few common tools that are kind of usable by everybody, so that when we do have to jump in there and like kind of save people from like something that they've shipped or they don't understand, we kind of know like that the platform which is doing the monitoring, like we kind of know how to use it, and we know that all the metrics are all in one place so we can correlate them against each other. So we really only have like a couple of tools, and we try to make sure that those tools are as usable and as broad by every engineer as possible. Because like if the tools are really difficult to use, then no one's going to use them. Like it can't just be like a super complicated UI. It has to be like pretty straightforward. Like it can't. You shouldn't have to ramp up for weeks to be able to use the monitoring tools that you're using every time you have to ship code. And finally, we really want our monitoring infrastructure to be treated just like any other app. Like it's not something special. It's not something people configure. You deploy it in many cases the same way you would deploy any other application, or you kind of configure it or automate it the same way as you automate the rest of your infrastructure. So a lot of what I'm going to be talking about is like how to automate your monitoring infrastructure. There's a lot of monitoring tools out there. I know that in the keynote address, like Facebook talked about some of the tools that they've built, and it seems like, how can I get there? Like I don't have time to build all of this like amazing tooling. I think that you can use a lot of the tooling that is there like kind of off the shelf. I just think that you have to have kind of a list of requirements that you go with. A lot of monitoring tools are really designed around like an operations team, which kind of installs the tool, and then every time they want to monitor something, they like go into UI and they like click a bunch of buttons and they like set up a new like host or whatever and like set up some alerts and stuff. And that just really doesn't scale. A, like no one really wants to do that job, and B, you're gonna like miss a lot of things. Like things are just not gonna get monitored. So if you're using a hosted tool, which is like a third-party tool, which is a lot of what I'm talking about, I want to make sure that that tool like really has an API so that I can automate all of the things that it does. And I'm going to talk about the alerts framework, which kind of does that for Datadog. And if you're running something on premises, it really has to be like easily manageable through configuration management. I know like Nagios is extremely popular, and you can kind of configure Nagios with configuration management, but it's hard to get data out of Nagios. Like you have to do this crazy stuff with parsing status.dat and stuff. So that like almost maybe kind of half qualifies. I wish it had a better API. What tools did Airbnb choose to monitor our infrastructure? So this is kind of our stack. I kind of split monitoring into two problem domains. One problem is logging, and the other problem is kind of metrics, or what I think of as monitoring. And the difference between them, it can be hard to figure out what falls into which like category. I think in general, logging is anything that has the potential to contain PII. Like if a log line accidentally contains someone's like phone number or address or whatever, you probably don't want to be sending that to a third party. At least this was important for us. So the reason why I say almost no infrastructure is because we actually run our own Logstash Elasticsearch Kibana cluster in our infrastructure. just because we didn't want to be sending potentially sensitive information to third parties. But for kind of the metrics level monitoring, that data tends to be pretty anonymous. It's like aggregates, like this is the number of visitors we had, not like this visitor is Bob. So for that, I think it's like perfectly okay to use third parties. And I'll talk about NewRelic and Datadog and how we use them. So let me start with Logstash. This is a screenshot of Kibana 3, which is an aggregate kind of search tool over your logging infrastructure. The way that Logstash, Kibana, Elasticsearch work, they're 3 separate tools. Logstash kind of receives data from your syslog infrastructure, and then it can take actions with that data, such as putting that data in Elasticsearch, and it does stuff like tagging that data so you can search it more easily and like kind of parsing the log lines that you're looking at. And then Elasticsearch actually provides a search functionality so you can like query the data in real time. And Kibana is the front end for Elasticsearch, so you can kind of look for the log lines you're interested in. So it's kind of hard to see, but in this search, I'm searching for all HA proxy transactions that go to a particular service. If you read some of our service discovery talks, you know that we use HA proxy to communicate between all of our services. So by looking just at our HA proxy logs, which are already tagged HA proxy, we can kind of see which services are talking to which other services and just kind of get a complete picture of what the traffic flows between them look like. Besides just like searching for log lines, with Kibana 3, you can build these cool dashboards. This is Thrawn Errors. So this is an HTTP client that all of our Ruby applications use, and it just kind of shows you like it has like these really strong circuit breaking semantics, so you can see like which services are failing and being circuit broken inside this like web service client. So this is just like someone put together a couple of searches and then like just define several views over the data, and this is just like this is generated just from pure log lines like streaming into our syslog. So it's a really cool tool. One amazing benefit of it is this is like one log line from HA proxy. Like HA proxy is really good at logging stuff, and it'll print you extremely detailed information about what happened with your TCP connection, but it prints it out in this format that's like 0/0/0/0/0/1, and you're like, do I really have to read the documentation like every time I want to look at one of these log lines? The benefit is that with Logstash, you can have it pre-parse your log lines. So you can see here, there's like a bunch of different fields, and they're already tagged like FECon or like response code or like data. So like then when you're looking at a problem with like 2 services talking to each other, you can just like, you don't have to like figure out what the different fields mean. It's already like all labeled there for you. This is kind of the logging. Let me talk a little bit about NewRelic. So NewRelic is probably kind of like the most important component of the infrastructure as far as enabling engineers. I don't know how many people use NewRelic, but it kind of sits inside your application, and it has a complete view of everything that your application is doing. And it can give you like really detailed breakdowns as to what's happening. So usually when we have engineers deploy code, we tell them like every service that they would possibly deploy already has a NewRelic agent inside it, and we tell them to look at NewRelic when they're doing that. And from there they can see stuff like when the deploy happened, we'll like publish deploy lines to NewRelic because they have a really good API, and then you can see like if the error rate is going up, or if like something like the database time is increasing, then like maybe something was bad inside the deploy you just made and you should maybe roll back, or like try to figure out what the problem is so you can roll forward. You can basically dig into almost any one of these sections. Like this is me just clicking on the error rate, and it'll tell me like a detailed view of what the errors are, and you can like sort by which exceptions are actually happening, and if I click on the exception, it'll even give me the traceback. This is kind of like your all-in-one like error tracking, like what happened after I deployed, which errors started happening kind of application. And it has really deep introspection as far as like which other services your application is talking to. This is a breakdown of like which services are receiving requests from like this as child services, and you could click on any one of these services and see like what kind of requests are being made. So this is just like kind of a comprehensive logging platform, and we didn't have to build this. Like NewRelic kind of built it for us. We don't have to operate it. Like it doesn't really like they have their own SLAs for it. It doesn't really go down. So like it's just like always available for us. So that's really convenient. And this is something that we kind of use for application monitoring. So this is really important for deploying a specific application. We use Datadog more for systems monitoring, although we also use it for application, and I'll tell you how. So this is an example of a Datadog dashboard. I think this is that same database dashboard that I was showing you earlier. The reason why Datadog is really great is because we run on AWS. And so that means because we use services like RDS that we don't actually have control over the instances that run the services. So like there's no like MySQL machine that I can install an agent on. And so usually like for people who run on AWS, they'd be limited to going into the AWS console to see the different metrics for a different database. But that UI is really not that great, and it's kind of sitting all on its own, so you can't correlate the stuff that's happening in there with like the stuff that's happening in the rest of infrastructure. So like one of the reasons why I really like Datadog is because it has like a lot of integrations, including with NewRelic and AWS and a lot of our existing applications that we run ourselves. So all the data gets like automatically sucked in, and you can kind of visualize it all in one place. In this particular dashboard, some of these metrics we're reporting ourselves by processing like MySQL status tables, and some of the data comes directly from AWS. So like the stats at the top, we like parsed ourselves, and then the stuff at the bottom that's like AWS RDS, that stuff is getting pulled in from the CloudWatch metrics that AWS provides you. And that kind of gives you like a unified UI. And one problem that people often have is they don't want to give people access to the AWS UI because that's a dangerous place, and it's kind of hard to use anyway. But with this, we don't have to. So like no one has an AWS like console access except for like a few production engineers. Besides just like monitoring metrics, we use Datadog for building dashboards. It's kind of like Graphite. You can do like arbitrary kind of math in your metrics. So this is an example of looking at the 500 error rate. So this metric is constructed just by taking the 500 rate divided by the overall rate. And I can just like, kind of declare it the way that I do any other math. And you could do kind of arbitrary math on this stuff. And then Datadog also provides us with our alerting infrastructure, which I'll talk a little bit more about in a second. But you can kind of declare what conditions should raise an alarm with which teams. We don't use the UI to do that. We use the API to do that. So this is kind of like a bunch of different tools. How do you like make use of all these tools? How do you kind of weave them into a comprehensive platform? Most importantly, how do you make sure that they're actually available? How do you make sure that the data that you need is actually going to be there when you're in the middle of an incident? Like, oops, we forgot to install the agent on this box, and so like something's broken, but we have not been gathering enough data, or like we don't have the historical data to understand how things have changed or something. So it doesn't matter which applications you use for your logging or monitoring infrastructure. What matters is like, do the tools you use have the features you need? And for different people, these might be different features. Like maybe some people are not on AWS, and so they don't need this like strong AWS integration. This is an important feature for us. Maybe some people are working in a more privacy-sensitive context, and so they can't afford to ship their data to a third party. That would be an important feature for them. That's not important for us. But then like once you found the tool that you think you like, that tool is not really actually worthwhile until you can automate it. And if you can't automate it, then I would argue that you should not even bother with it. So Logstash is kind of a no-brainer for us for how to automate it because it's just kind of a traditional systems tool. Like it is basically an infrastructure service. Like there's no application except like what we set up with configuration management. And so there, like things are pretty simple. Like you set up your application to log to syslog. Most applications already log to syslog. If your applications are not logging to syslog over UDP, you should make sure that that happens. And then you just like set up our syslog forwarding on each of your boxes, and because we own the syslog configuration with configuration management, that is also like automated for us to do. And then you make sure that the syslog traffic goes to a series of Logstash collectors, and we have a whole service registration discovery framework which we've open sourced, and that just kind of like fits right into that picture. Like HA proxy on each machine just provides you with a gateway to Logstash, and so it just like will automatically round robin. So that's kind of like the easiest thing. You just like set it up as an application, and then it's like it like is good to go. And there's no really deploys because you're not working on it actively. With NewRelic, it's a little bit tougher because you have to make sure that you install the agent into each of your applications. In order to make sure that we always have certain common things happen, such as monitoring when we set up our services, we've created a couple of like abstraction wrappers in our configuration management that set up the applications for us. So mostly Airbnb is a Ruby shop with a lot of Java. So we have kind of two helpers. One is Java service. This is basically like an entire config for a service called the Signal service, which is used by Trust and Safety to like figure out whether people are fraudsters. Like one of the top line options is NewRelic agent. And if you just like all you have to do is specify yes, and the NewRelic agent will when we set up your service in configuration management, we will include the NewRelic jar as like part of the JVM. And that like does the needful to make sure that your service gets monitored. For Ruby, it's a little bit harder. You have to like set up these configs. So we just created a little wrapper called NewRelic Ruby, and that kind of does the same thing for Ruby applications. It just like sets up the initializers and sets up the configuration files so that you don't have to think about it as a developer. All you know is when your service is running on production machines, if you've like kind of followed the best practices recipe, then you would just like automatically get the agent. And this has resulted in us just having like every application in NewRelic, which is like nice because you could just tell people like it's already there. Like if you start working on a new application, you would just get this kind of stuff for free. Datadog is also pretty easy in the sense that setting up the actual agent on the different boxes to keep an eye on the boxes is pretty straightforward. Like we just like always run an agent. This is on the left, you see the Airbnb common role, and that just like by default sets up Datadog and then sets it up to monitor a few standard things. So for us, it's Smart Stack, which is a service registration and discovery framework, and that all the pieces of that are automatically monitored. And we also monitor the agent itself with itself to make sure that it's not doing anything crazy, like consuming a lot of CPU. For something like Redis, we run a lot of Redis boxes, and we want to make sure that if someone spins up a new Redis box, then the Redis service on that machine is being monitored. So those just all inherit from like a common Redis role that sets up Datadog to watch Redis on localhost. But besides the system level monitoring that Datadog provides, you might also want to do some in-application kind of monitoring. One of the reasons why we really like Datadog is because every local Datadog agent also acts as a statsd agent, which sends the data to Datadog. So inside most of our applications, we configure like a statsd client that lives on localhost on just a normal statsd port. And so we encourage people within applications, if they're like need to watch a particular thing, just to like always be sending stuff to statsd. And that's really useful because it allows us to correlate the systems metrics that the Datadog agent is gathering on each box with the kind of the application metrics that come from inside the application, like what is the application actually doing. Let's take a quick break because I think I've been going pretty fast and I've covered like a lot of stuff. So the stuff that we've covered so far has been that we really want to enable engineers at Airbnb to move quickly. We do this with a variety of ways by like mostly by providing them with tools that they need to ship the code that they want to ship. I've also told you about a couple of the monitoring tools we use and kind of how we weave them together into a monitoring framework. And I've also showed you how it's really important to set up monitoring in an automated fashion to make sure that it's always available so you don't have to think about, is this monitoring going to be there when I need it? So the next question you might ask yourselves is, so do you guys just like sit around like looking at these graphs that you're showing us like basically all day long? And the answer is no, because we have junior engineers who we've hired to watch the graphs for us, so we can be free from that responsibility. This is actually the daughter of one of our production infrastructure engineers. He's getting her trained really early. Actually, no, we configure robots to watch our metrics for us, and the robots will tell us if something is wrong. So the way this works is Datadog is kind of our single point of integration for all kind of metrics because it pulls in all the metrics that we're gathering. And if something goes wrong, then Datadog alerts PagerDuty, which of course causes PagerDuty to alert me, which is not great. So if I get an alarm at 4:30 in the morning, I want to know that there's a good reason. I want to know first that there are alarms that are gonna like alert me at 4:30 in the morning. Like, what are these things? And the second thing I want to know is like, I didn't have anything to do with this. Like, someone just set this alarm up to page me. Like, that's not cool. And I just want to make sure that if I do get an alarm that is worthwhile, I can like look at the alert and just be like, is this alert actually useful? Like, do I actually need to take action? Like, am I gonna get on my computer and just be like, I don't know what's broken. Like, this alarm like didn't tell me anything. In order to do this, we have kind of thought about how to set up alerting based on your metrics, and there's kind of a couple of rules. So one rule is that if you spin up a new host, you should automatically have alerting. Like, you shouldn't like forget that a certain host should have alerts. Another rule is that you shouldn't have like a ton of alerts. Like, you should try to pick like which are the key alerts and like just make sure that those cover kind of the gamut of the things that could possibly go wrong with your application. I also really want alerts to be descriptive. Like, I don't want to just get an alert that says problem, like I want it to say like, here's the problem, here is some potential causes of this problem, and here are some things you can do to resolve the problem. And if it doesn't have that, I don't want to get that alert. And they want to be consensually created. Like I should have like input on which alerts people are creating, and if these alerts are mentioning me, I should kind of know about it, and I should be able to like, like suggest things about the alert that maybe the person creating the alert didn't consider. So in order to do all this stuff, we've built an alerts framework which automates the creation of all of this stuff and keeps the alerts in configuration management so that you can create alerts just like you do any other code. This is like just a standard DevOps like toolkit thing, configuration as code. So I'll give you an example. This is an example from our alerts framework of a DynamoDB alert. This is like the whole thing. This one doesn't have a super descriptive message because there's ultimately not much you can do. So the DynamoDB is a service that Amazon provides. That's a key value store. And you kind of provision your like read-write settings. And then if you know that you're going to be facing more load, or if your load is increasing, you have to re-provision it. You have to like take action with Amazon to say like double or whichever the number of like read operations I can do in a given time interval. And we just don't want to be caught off guard. Like if someone creates a new DynamoDB table, like how do we know that it's not just going to like max out like when like someone launches some new feature and like causes problems for some unrelated features? So this alert just like covers all of our DynamoDB tables. And the reason why it knows to cover all of our DynamoDB tables is because we have a DynamoDB host source, this is all of it. This is like the whole file. There's a bit of initialization of the AWS client, but it basically just uses the Amazon API to retrieve a list of our DynamoDB instances, including what their current read allocation is and what their Datadog is already scraping AWS to pull like what the current read levels are. And so based on this like inventory source and the data that we're already gathering in our monitoring systems, we can just like automatically have the alert created. And we just kind of run this thing like every hour, and every hour it'll pick up the new hosts that have been created and we'll create the alerts. And if you adjust the threshold in AWS, you don't have to do anything to adjust the alert. The alert will like automatically adjust because it'll pick up that you've adjusted the threshold from the AWS API. This is kind of this is another example alert. This is from a system called Rescue, which is like a standard Ruby queuing alert. This is kind of more what I like to see when people create alerts as far as like what the messaging should be. It's got like a bunch of reasons for what could go wrong. It has links to like where you can go to discover more information about the specific problem you're being alerted on. It has like some dashboards you can look at to see historical trends. And it has like some steps you can take to like resolve the problem. And this is kind of like the one alert that covers all of our rescue queues. So there's only one of these. You can kind of tell that it's set to notify kind of the owners. So this will go to the people who kind of own the queue. Like if I'm like, if my team has its own rescue queue, then only I should get the alert. Like it shouldn't go to the sysops team who will then like just push it on down to your team anyway. And so this is another example of a host source. This is like a pretty like custom source. So this is maybe not something you would find in the open source project, but like it just kind of lists the queues. And if there's a specific owner for that queue, it just lists who the owner is. So if you like want to monitor a new queue, you just go in here. But this means that when you create new alerts, you can submit it as a pull request. Like, hey, I want to like make sure that I have a new rescue queue or something, and it's the alerts about that should go to these 5 people. So you make a pull request. You like make your change like for the rescue situation. It would just be like adding a single line that lists the queue and who the people should be, or for some new source, whichever that might be. And then people can kind of weigh in. They're like, oh, like this alert would not be helpful to me if I got it in the middle of the night. Like maybe you can add the following information to it. Or like, oh, maybe this metric is not exactly the metric we should be monitoring. And this is the kind of stuff that I really wanted to enable with the alerts framework, because a lot of the times what we saw is that when people were creating alerts, they would just kind of go into a UI and they would just click some buttons, and then eventually you'd have an alert, and then you'd have no history of that. And it's kind of reaction to the same kind of problems you would see over and over again. Like either someone would forget to set up an alert for a particular thing, or maybe there was an incident and someone temporarily changed a threshold, but they forgot to change that threshold back. That's like not something that we want to see happen. And the alerts framework even, it's like all of our applications, it's like really well instrumented so that it like keeps track of its own like running information, and kind of, you can see at a glance like what's been happening inside of it. So if you liked this framework, We're open sourcing it. So I've open sourced one piece so far today, which is like the gem that just contains like the framework itself. And it probably needs another piece, which is like an example repo. And that piece we haven't had a chance to put together yet, but stay tuned for our Nerds blog. When we open source the whole thing, then there's going to be a post about it on our Nerds blog. I guess I'm probably going to end up finishing kind of early, but I have a lot of, like, if people have questions. So just to sum up, like, what we've talked about during this presentation. So we talked about kind of the monitoring tools that Airbnb uses to keep an eye on its infrastructure. We talked a little bit about how we pick those tools, like what are some of the design considerations. And those considerations are really, can it be automated and does it have the right features? And we talked about how we like automate the alerting on those metrics that we've gathered using the alerts framework. So that's pretty much what I had. Do people have any questions for me about this? Yeah, Travis.
Why do you guys use UDP for your syslog? How do you keep track of failed messages?
So the reason why we can use UDP for syslog is because the syslog agent is running, like we have a local R syslog agent, right? And that takes care of forwarding to the Logstash cluster over TCP. We've found that UDP over localhost is incredibly reliable. Like you basically never see packet loss if you're talking on UDP from localhost to localhost. However, what you really don't want is for your rsyslog service to become like backed up in some way. And because you're trying to make TCP connections, like which you're making a lot because you're putting logs all the time, you don't want your whole application to get stuck like trying to pump out like a logging message. Like you want it to like send out the message and then move on. So all of the monitoring infrastructure that we have inside our applications is always UDP. For syslog, we have a UDP syslogger, and most of the stuff we use for metrics is statsd, and statsd is also a UDP protocol. And because the Datadog agent lives locally on the box, that's again UDP to localhost. So you don't really miss the.
But going from the local host to like
that part's TCP. Yeah, but like if the agent gets stuck, nobody cares. I mean, you might lose metrics for that particular host or whatever, but you just don't want your application to come crashing down because something's wrong with your monitoring infrastructure. Yeah, it's just the decoupling mechanism. Yeah.
Early on, you noted that you are trying to automate everything and that it's really easy to add new nodes into the logging infrastructure.
Mm-hmm.
What are you doing to ensure that the logs are actually getting from the servers to the log nodes? Do you have an automated way to know that there's not a firewall in the way that might contain the routing?
Yeah, so we do sometimes have problems with our logging infrastructure, and those problems tend to be usually more the other way, like someone has done something that is now pushing like billions of log messages like every microsecond to like our logging infrastructure, and that is going to be tough for us to handle. And we just monitor that the same way we monitor everything else. Like Logstash is a buffer that buffers log messages into Redis, and if we notice that those Redis queues are becoming too full, then we have alerts about that. Likewise, if the amount of traffic drops below like what we expect to be a usual level, we have alerts about that as well. So like that kind of like covers your like system-wide kind of stuff. So there's like another category of problem, which is that maybe a particular host is starting to fail to log, and that I think we don't do as good a job monitoring. But I don't think it just hasn't been a problem, so we haven't like probably set up automated alerting on that. Cool. Either I was really, oh yeah, right there. So you can set up alerts with NewRelic, and they do have an API for that. So there's no reason why in the alerts framework we shouldn't be able to just add a NewRelic destination. It's all kind of decoupled, so you can add a destination that will like interact with the API to set up alerting there. We just haven't done that, and the reason why we haven't done that is because Datadog actually has a NewRelic integration. So all the metrics, like not at the same granular level, but on like the overall levels, all the metrics we see in NewRelic we can also see in Datadog. So if we do one, and it just tends to be a little bit easier to like Datadog already knows who our users are, and people already know that like what Datadog alerts look like. So it's just a little bit easier to keep the alerting in one place for now. But that said, there's no reason why we shouldn't be able to create things like NewRelic. I think they're called alarms in that UI, or even like CloudWatch alarms. If you like really just want to stick with CloudWatch, we should be able to automate that as well. We just find that it's just easier to do in Datadog, and they provide you with like better features. Like I can do things like alert on the difference between this metric and this metric last week or something. And that's something that I probably wouldn't be able to do inside NewRelic, because their alerting infrastructure is not as fully fleshed out. Yeah, I mean, it would be tough if we were having an outage and Datadog was also having an outage. That would be like a bad situation for us. But that said, they've been like pretty reliable in my experience. Like I haven't really seen any outages from them. Yeah, I don't mean to sound like a Datadog show, but I'm a huge fan of Datadog. They've also been like really willing to implement features for us when we've asked them for them. Yeah. Yeah, I mean, so this is the internet, right? Like, the network is reliable. So the Datadog agents kind of act as buffers of the stats. So like, if it can't talk to the Datadog service, it will just kind of keep buffering the stats and then send them in later. But no, we haven't really seen like usually when the AWS network is like not the most reliable network, like by a long shot. But usually the kind of problems that we see inside the AWS network are internal. Like we have like certain services being disconnected from each other. Like there's like weird network partitions inside AWS. But we haven't really seen any network partitions of our network from like the public internet. But yeah, like this doesn't like make things any better, right? Like if we were running our own monitoring infrastructure inside AWS and there was a weird network partition that segregated like half of our like nodes in one availability zone from another availability zone, it would be the same kind of problem, right? Like those nodes were no longer getting telemetry data from. But it's the same thing, like, 6 of one, half dozen the other. So I don't know if that answers your question. Yeah, the network is not reliable. Like everything is going to get cut off from everything else. That's just the fact of life. Yeah. Yeah, so we don't have any physical hardware for Airbnb. We run entirely in AWS. Logstash itself performs pretty well. When we slam it with too much traffic, it tends to go under a little bit. Like, we have it provisioned to our expected capacity, and every once in a while, like, we notice that, like, that's not enough because our business is growing so rapidly, so we have to provision additional capacity, but it pretty much scales horizontally. A bigger problem is the Elasticsearch capacity. Just because the way Elasticsearch works, like that cluster is actually pretty expensive to operate because you want to you're actually storing a lot of state, and it kind of has to sit in memory, or it like takes too long to search for your metrics. So we only keep the last, I think, 3 weeks of data like readily available, and then it kind of goes into long-term archival. So if you need to look at your logs from like a long time ago, you're gonna have to like pull up the segments and like kind of grub through them manually, which is like a horrible process, but hopefully you catch your problems quickly enough that you don't have to go looking 4 weeks back through the logs. It's something totally insane. Like we have like billions of log messages per day. It's like, yeah, we occasionally have pushes to be like, okay, our syslog is like a line-based protocol. So if you log a traceback from Java and that traceback is like 300 lines because it's Java, then like the 290th line would just have no context. Like it would just be like a random exception traceback, like floating in the air. And so we occasionally have pushes that are like, okay, like who's been abusing our logging infrastructure? Like, can we just like tone it down a little bit in production? But it's kind of a pain. But that's just the way things are. I don't know how to solve that problem. Right there, I think.
So earlier on presentation, you had a rule out list. Criteria that kind of accepted something from being considered.
Yeah.
And I noticed on the on-premise side, you have a settlement that was kind of
The XML. Yeah. So.
I'm just wondering, is that like native ability
Well, so I want engineers inside our organization to be able to write the like pieces that they need. So like if it's like a DSL file that kind of makes sense to someone and they can just kind of write it and it like now they have an alert, that's one thing. But if someone has to write like an XML file in an unfamiliar schema to get some kind of usability, like I don't want to write that for them. Like they have to be able to do it. And so like if the form, like if you can in theory configure something with configuration management, but in practice like only like the most like powerful of neckbeards would ever be able to write this config file, then like it doesn't matter. Like it's not useful. Yeah, sorry Travis. Yeah. Do we use it for what? I'm sorry? We use a lot of Elasticsearch in the Airbnb infrastructure. It's like a huge part of what we do. People tend to build like if you follow our open source blog, mostly what we use for analytics, especially like company wide, is Presto, and we just open source the UI for Presto that is like pretty usable. That kind of makes data accessible to just like most people inside the company. In terms of like specific targeted tools, like trust and safety investigators who are like trying to figure out whether like a particular booking is like possibly like a money laundering scheme, like those people need like more in-depth tools to like dig into the data. And so for those people, we do maintain Elasticsearch clusters that are like loaded with like some recent amounts of data that they can run like really complicated queries on that are fast. Although Presto is also like pretty fast, yeah, like I'm not super familiar with that tooling. That's all like I know that this stuff exists, but I don't know exactly what it does. Nope, I don't think so. It seems to be fairly easy to operate. Yeah. Mm-hmm. Yeah, so in the alerts framework, we kind of assume that certain data sources are available. And so one thing that it is tied to is that we have our own inventory system, right? Like you need sources of inventory. Like there's a couple of places that pull in data. And so the ones that I showed you guys have been things like it pulls data from AWS, like to list the DynamoDB boxes. It pulls data from RDS instances. But we also want to do things like pull data from our own inventory system to list like machines that we know about, or like for our like smart stack use case, we also list like in our inventory system which services exist and how they connect to each other. So I can create alerts like this service is required, but its available backends has fallen below a certain threshold, so like that's an alertable condition. And for that kind of stuff, we pull in data from our own inventory system, which like we have to maintain. And if you use like Chef Server kind of maintains an inventory system. We use Chef Solo, so we actually open sourced a tool called Optica, which like is an internal inventory system. It's got really simple JSON API, and actually like having a really simple JSON API that gives you inventory data is incredibly useful for all of our monitoring infrastructure. Like in Logstash, for instance, all of the log lines are tagged based on the information in the inventory system. So if I want to look at just log lines from a particular for a particular type of machine, I can like search for that because it gets pulled in by Logstash. And likewise for alerting. And then again, like I assume in the alerts framework that like the data sources will be available, or I can create alerts that say that if the data source is not available, that's also an alertable condition. But they're kind of decoupled, right? Like I don't do the work of setting up the monitoring in the alerts framework. I just kind of assume that it exists. And I feel safe making that assumption because the setting up of the alerting is in configuration management, so I'm fairly confident that it's gonna like continue working. Cool. Those were great questions. Thanks, everybody. Yeah.